Chapter 4. The Messengers of Genesis. In 1986, mankind was treated to a once-in-a-lifetime event, the appearance of a messenger from the past, a messenger of Genesis. Its name was Halley's Comet. One of many comets and other small objects that roam the heavens, Halley's Comet is unique in many ways. Among them is the fact that its recorded appearances have been traced to millennia ago, as well as the fact that modern science was able, in 1986, to conduct for the first time a comprehensive, close-up examination of a comet and its core. The first fact underscores the excellence of ancient astronomy. Because of the second, data was obtained that, once again, corroborated ancient knowledge and the tales of Genesis. The chain of scientific developments that led Edmund Halley, who became British Astronomer Royal in 1720, to determine during the years 1695 to 1705 that the comet he observed in 1682 and that came to bear his name was a periodic one, the same that had been observed in 1531 and 1607, involved the promulgation of the laws of gravitation and celestial motion by Sir Isaac Newton and Newton's consulting with Halley about his findings. Until then, the theory regarding comets was that they crossed the heavens in straight lines, appearing at one end of the skies and disappearing in the other direction, never to be seen again. But, based on Newtonian laws, Halley concluded that the curve described by comets is elliptical, eventually bringing these celestial bodies back to where they had been observed before. The three comets of 1531, 1607, and 1682 were unusual in that they were all orbiting in the wrong direction, clockwise rather than counterclockwise, had similar deviations from the general orbital plane of the planets around the Sun, being inclined about 17 to 18 degrees, and were similar in appearance. Concluding they were one and the same comet, he plotted its course and calculated its period, the length of time between its appearances, to be about 76 years. He then predicted that it would reappear in 1758. He did not live long enough to see his prediction come true, but he was honored by having the comet named after him. Like that of all celestial bodies, and especially because of a comet's small size, its orbit is easily perturbed by the gravitational pull of the planets it passes. This is especially true of Jupiter's effect. Each time a comet nears the Sun, its frozen material comes to life. The comet develops a head and a long tail and begins to lose some of its material as it turns to gas and vapor. All these phenomena affect the comet's orbit. Therefore, although more precise measurements have somewhat narrowed the orbital range of Halley's comet from the 74 to 79 years that he had calculated, the period of 76 years is only a practical average. The actual orbit and its period must be recalculated each time the comet makes an appearance. With the aid of modern equipment, an average of 5 or 6 comets are reported each year. Of them, 1 or 2 are comets on return trips, while the others are newly discovered. Most of the returning comets are short-period ones, the shortest known being that of Encke's comet, which nears the Sun and then returns to a region slightly beyond the asteroid belt in a little over 3 years. Most short-period comets average an orbital period of about 7 years, which carries them to the environs of Jupiter. Typical of them is Comet Giacobini-Zinner, named, like other comets, after its discoverers, which has a period of 612 years. Its latest passage within Earth's view was in 1985. On the other hand, there are the very long-period comets like Comet Kohoutek, which was discovered in March 1973, was fully visible in December 1973, and January 1974, and then disappeared from view, perhaps to return in 75,000 years. By comparison, the cycle of 76 years for Halley's Comet is short enough to remain in living memories, yet long enough to retain its magic as a once-in-a-lifetime celestial event. When Halley's Comet appeared on its next-to-last passage around the Sun in 1910, its course and aspects had been well mapped out in advance. Still, the Great Comet of 1910, as it was then hailed, was awaited with great apprehension. There was fear that Earth or life on it would not survive the anticipated passage because Earth would be enveloped in the comet's tail of poisonous gases. There was also alarm at the prospect that, as was believed in earlier times, the appearance of the comet would be an ill omen of pestilence, wars, and the death of kings. As the comet reached its greatest magnitude and brilliance in May of 1910, its tail stretching over more than half the vault of heaven, King Edward VII of Great Britain died. On the European continent, a series of political upheavals culminated in the outbreak of World War I in 1914. The belief, or superstition, associating Halley's comet with wars and upheavals was fed by much that was coming to light about events that coincided with its previous appearances. The Seminole Indians' revolt against the white settlers of Florida in 1835, the Great Lisbon Earthquake of 1755, the outbreak of the 30 Years' War in 1618, the Turkish siege of Belgrade in 1456, the outbreak of the Black Death, bubonic plague, in 1347, all were accompanied or preceded by the appearance of a great comet, which was finally recognized as Halley's Comet, thus establishing its role as the messenger of God's wrath. Whether divinely ordained or not, the coincidence of the comet's appearance in conjunction with major historic events seems to grow the more we go back in time. One of the most celebrated appearances of a comet, definitely Halley's, is that of 1066, during the Battle of Hastings, in which the Saxons, under King Harold, were defeated by William the Conqueror. The comet was depicted on the famous Bayeux Tapestry, which is thought to have been commissioned by Queen Matilda, wife of William the Conqueror, to illustrate his victory. The inscription next to the comet's tail, Isti Mirant Stella, means, "They are in awe of the star," and refers to the depiction of King Harold tottering on his throne. The year AD 66 is considered by astronomers one in which Halley's comet made an appearance. They base their conclusion on at least two contemporary Chinese observations. That was the year in which the Jews of Judea launched their great revolt against Rome. The Jewish historian Josephus, Wars of the Jews, Book 6, blamed the fall of Jerusalem and the destruction of its holy temple on the misinterpretation by the Jews of the heavenly signs that preceded the revolt. A star, resembling a sword which stood over the city, a comet that continued a whole year. Until recently, the earliest certain record of the observation of a comet was found in the Chinese chronological tables of Sitchin for the year 467 BC, in which the pertinent entry reads, "During the 10th year of Jin Li Kung, a broom star was seen." Some believe a Greek inscription refers to the same comet in that year. Modem astronomers are not sure that the 467 BC Sitchin entry refers to Halley's comet. They are more confident regarding a Sitchin entry for the year 240 BC. In April 1985, F.R. Stevenson, K.K.C. Yao, and H. Hunger reported in Nature that a re-examination of Babylonian astronomical tablets that had been lying in the basement of the British Museum since their discovery in Mesopotamia more than a century ago shows that the tablets recorded the appearance of extraordinary celestial bodies, probably comets, they said, in the years 164 BC and 87 BC. The periodicity of 77 years suggested to these scholars that the unusual celestial bodies were Halley's comet. The year 164 BC, as none of the scholars who have been preoccupied with Halley's comet have realized, was of great significance in Jewish and Near Eastern history. It was the very year in which the Jews of Judea, under the leadership of the Maccabees, revolted against Greek-Syrian domination, recaptured Jerusalem, and purified the defiled temple. The temple rededication ceremony is celebrated to this day by Jews as the festival of Hanukkah rededication. The 164 BC tablet, numbered WA 41462 in the British Museum, is clearly dated to the relevant year in the reign of the Seleucid, Greek-Syrian, King Antiochus Epiphanes, the very evil King Antiochus of the Books of Maccabees. The unusual celestial object, which the three scholars believe was Halley's comet, is reported to have been seen in the Babylonian month of Kislevu, which is the Jewish month Kislev, and indeed the one in which Hanukkah is celebrated. In another instance, the comparison by Josephus of the comet to a celestial sword, as it seems to be depicted also in the Bayeux tapestry, has led some scholars to suggest that the angel of the Lord that King David saw, standing between the earth and heaven, having a sword in his hand stretched out over Jerusalem, I Chronicles 21:16, might have been in reality Halley's comet, sent by the Lord to punish the king for having conducted a prohibited census. The time of this incident, circa 1000 BC, coincides with one of the years in which Halley's comet should have appeared. In an article published in 1986, I pointed out that the Hebrew name for comet is Kokav Shavet, a Scepter Star. This has a direct bearing, I wrote, on the biblical tale of the seer Bilam. When the Israelites ended their wanderings in the desert after the Exodus and began the conquest of Canaan, the Moabite king summoned Bilam to curse the Israelites. But Bilam, realizing that the Israelite advance was divinely ordained, blessed them instead. He did so, he explained, Numbers 24:17, because he was shown a celestial vision. I see it, though not now. I behold it, though it is not near. A star of Jacob did course. A scepter of Israel did arise. In The Stairway to Heaven, I provided a chronology that fixed the date of the Exodus at 1433 BC. The Israelite entry into Canaan began 40 years later in 1393 BC. Halley's comet, at an interval of 76 or 77 years, would have appeared circa 1390 BC. Did Bilam consider that event as a divine signal that the Israelite advance could not and should not be stopped? If, in biblical times, the comet we call Halley's was considered the Scepter Star of Israel, it could explain why the Jewish revolts of 164 BC and AD 66 were timed to coincide with the comet's appearances. It is significant that in spite of the crushing defeat of the Judean revolt by the Romans in AD 66, the Jews took up arms again some 70 years later in a heroic effort to free Jerusalem and rebuild the temple. The leader of that revolt, Shimeon bar Kosiba, was renamed by the religious leaders Bar Kokhba, son of the star, specifically because of the above-quoted verses in Numbers 24. One can only guess whether the revolt the Romans put down after 3 years, in AD 135, was also to achieve the rededication of the temple by the time of the return of Halley's comet, in AD 142. The realization that we, in 1986, have seen and experienced the return of a majestic celestial body that had great historic impact in the past should send a shudder down some spines, mine among them. How far back does this messenger of the past go? According to the Sumerian creation epics, it goes all the way back to the time of the celestial battle. Halley's comet and its like are truly the messengers of Genesis. The solar system astronomers and physicists believe was formed out of a primordial cloud of gaseous matter. Like everything else in the universe, it was in constant motion, circling about its galaxy, the Milky Way, and rotating around its own center of gravity. Slowly the cloud spread as it cooled. Slowly the center became a star, our sun, and the planets coalesced out of the rotating disk of gaseous matter. Thenceforth, the motion of all parts of the solar system retained the original direction of the primordial cloud, anti-clockwise. The planets orbit the sun in the same direction as did the original nebula. So do their satellites or moons. So should also the debris that either did not coalesce or that resulted from the disintegration of bodies such as comets and asteroids. Everything must keep going anti-clockwise. Everything must also remain within the plane of the original disk, which is called the ecliptic. Nibiru Marduk did not conform to all that. Its orbit, as previously reviewed, was retrograde, in the opposite direction, clockwise. Its effect on Pluto, which according to the Sumerian texts was Giage, and was shifted by Nibiru to its present orbit, which is not within the ecliptic but inclined 17 degrees to it, suggests that Nibiru itself followed an inclined path. Sumerian instructions for its observation, fully discussed in the 12th planet, indicate that relative to the ecliptic, it arrived from the southeast, from under the ecliptic, formed an arc above the ecliptic, then plunged back below the ecliptic in its journey back to where it had come from. Amazingly, Halley's comet shows the same characteristics, and except for the fact that its orbit is so much smaller than that of Nibiru, currently about 76 years compared with Nibiru's 3,600 Earth years, an illustration of Halley's orbit could give us a good idea of Nibiru's inclined and retrograde path. Looking at Halley's comet, we see a miniature Nibiru. This orbital similarity is but one of the aspects that make this comet, and others too, messengers from the past. Not only the historic past, but all the way back to Genesis. Halley's comet is not alone in having an orbit markedly inclined to the ecliptic, a feature measured as an angle of declination, and a retrograde direction. Non-periodic comets, comets whose paths form not ellipses but parabolas or even hyperbolas, and whose orbits are so vast and whose limits are so far away they cannot even be calculated, have marked declinations, and about half of them move in a retrograde direction. Of about 600 periodic comets, which are now given the letter P in front of their name, that have been classified and catalogued, about 500 have orbital periods longer than 200 years. They all have declinations more akin to that of Halley's than to the greater declinations of the non-periodic comets, and more than half of them course in retrograde motion. Comets with medium orbital periods, between 220 years, and short periods, under 20 years, have a mean declination of 18 degrees, and some, like Halley's, have retained the retrograde motion in spite of the immense gravitational effects of Jupiter. It is noteworthy that of recently discovered comets, the one designated P. Hartley-IRAS, 1983V, has an orbital period of 21 years, and its orbit is both retrograde and inclined to the ecliptic. Where do comets come from, and what causes their odd orbits, of which the retrograde direction is the oddest in astronomers' eyes? In the 1820s, the Marquis Pierre-Simon de Laplace believed that comets were made of ice and that their glowing head, coma, and tail that formed as they neared the sun were both made of vaporized ice. This concept was replaced after the discovery of the extent and nature of the asteroid belt, and theories developed that comets were flying sandbanks, pieces of rock that might be the remains of a disintegrated planet. The thinking changed again in the 1950s mainly because of two hypotheses. Fred L. Whipple, then at Harvard, suggested that comets were dirty snowballs of ice, mainly water ice, mixed with darker specks of sand-like material, and Jan Oort, a Dutch astronomer, proposed that long-period comets come from a vast reservoir halfway between the Sun and the nearer stars. Because comets appear from all directions, traveling prograde or anti-clockwise, retrograde, and at different declinations, the reservoir of comets, billions of them, is not a belt or ring like the asteroid belt or the rings of Saturn, but a sphere that surrounds the solar system, this Oort cloud. As the concept came to be named, settled at a mean distance, Oort calculated of 100,000 astronomical units, AU, from the Sun, 1 AU being the average distance, 93 million miles, of the Earth from the Sun. Because of perturbations and intercometal collisions, some of the cometary horde may have come closer, to only 50,000 AU from the Sun, which is still 10,000 times the distance of Jupiter from the Sun. Passing stars occasionally perturb these comets and send them flying toward the Sun. Some, under the gravitational influence of the planets, mainly Jupiter, become medium or short-period comets. Some, especially influenced by the mass of Jupiter, are forced into reversing their course. This, briefly, is how the Oort cloud concept is usually stated. Since the 1950s, the number of observed comets has increased by more than 50%, and computer technology has made possible the projection backward of cometary motions to determine their source. Such studies, as one by a team at the Harvard-Smithsonian Observatory under Brian G. Marsden, have shown that of 200 observed comets with periods of 250 years or more, no more than 10% could have entered the solar system from outer space. 90% have always been bound to the Sun as the focus of their orbits. Studies of cometary velocities have shown, in the words of Fred L. Whipple in his book, The Mystery of Comets, that if we are really seeing comets coming from the void, we should expect them to fly by much faster than just 0.8 kilometers per second, which they do not. His conclusion is that, with few exceptions, comets belong to the Sun's family and are gravitationally attached to it. During the past few years, astronomers have questioned the simple view of Oort's cloud, stated Andrew Theokas of Boston University in The New Scientist, February 11, 1988. Astronomers still believe that the Oort cloud exists, but the new results demand that they reconsider its size and shape. They even reopen the questions about the origin of the Oort cloud and whether it contains new comets that have come from interstellar space. As an alternative idea, Theokas mentions that of Mark Bailey of the University of Manchester, who suggested that most comets reside relatively close to the Sun, just beyond the orbits of the planets. Is it perhaps, one may ask, where Nibiru, Marduk's distant abode, its aphelion, is? The interesting aspect of the reconsideration of the Oort cloud notion and the new data suggesting that comets, by and large, have always been part of the solar system and not just outsiders occasionally thrust into it, is that Jan Oort himself had said so. The existence of a cloud of comets in interstellar space was his solution to the problem of parabolic and hyperbolic cometal orbits, not the theory he had developed. In the study that made him and the Oort cloud famous, The Structure of the Cloud of Comets Surrounding the Solar System and a Hypothesis Concerning Its Origin, Bulletin of the Astronomical Institutions of the Netherlands, Volume 11, January 13, 1950. Oort's new theory was called by him a hypothesis of a common origin of comets and minor planets, i.e., asteroids. The comets are out there, he suggested, not because they were born there, but because they were thrust out to there. They were fragments of larger objects diffused away by the perturbations of the planets and especially by Jupiter, just as more recently the Pioneer spacecraft were made to fly off into space by the slingshot effects of Jupiter's and Saturn's gravitation. The main process now, Oort wrote, is the inverse one, that of a slow transfer of comets from a large cloud into short-period orbits. But at the epoch at which the minor planets, asteroids, were formed, the trend must have been the opposite, many more objects being transferred from the asteroid region to the comet cloud. It appears far more probable that instead of having originated in the faraway regions, comets were born among the planets. It is natural to think in the first place of a relation with the minor planets, asteroids. There are indications that the two classes of objects, comets and asteroids, belong to the same species. It seems reasonable to assume that the comets originated together with the minor planets. Summing up his study, Oort put it this way. The existence of the huge cloud of comets finds a natural explanation if comets and meteorites are considered as minor planets escaped, at an early stage of the planetary system, from the ring of asteroids. It all begins to sound like the Enuma Elish. Placing the origin of the comets within the asteroid belt and considering both comets and asteroids as belonging to the same species of celestial objects, objects of a common birth, still leaves open the questions. How were these objects created? What gave birth to them? What diffused the comets? What gave comets their inclinations and retrograde motions? A major and outspoken study on the subject was made public in 1978 by Thomas C. Van Vlandam of the U.S. Naval Observatory, Washington, D.C., Icarus 36. He titled the study, A Former Asteroidal Planet as the Origin of Comets, and openly subscribed to the 19th century suggestions that the asteroids and the comets come from a former planet that had exploded. It is noteworthy that, in the references to Oort's work, Van Vlandam picked out its true essence. Even the father of the modem cloud of comets theory was led to conclude, Van Vlandam wrote, on the basis of evidence then available, that a solar system origin for these comets, perhaps in connection with the occurrence which gave birth to the belt of asteroids, was still the least objectionable hypothesis. He also referred to studies begun in 1972 by Michael W. Ovenden, a noted Canadian astronomer who introduced the concept of a principle of least interaction action, a corollary of which was the suggestion that there had existed between Mars and Jupiter a planet of a mass of about 90 times that of Earth. Summarizing his findings, Van Vlandam said thus in 1978, "The principal conclusion of this paper is that the comets originated in a breakup event in the inner solar system. In all probability, it was the same event which gave rise to the asteroid belt and which produced most of the meteors visible today." He said that it was less certain that the same breakup event may have also given birth to the satellites of Mars and the outer satellites of Jupiter, and he estimated that the breakup event occurred 5 million years ago. He had no doubt, however, that the breakup event took place in the asteroid belt. Physical, chemical, and dynamic properties of the resulting celestial bodies, he stated emphatically, indicate that a large planet did disintegrate, where the asteroid belt is today. But what caused this large planet to disintegrate? The most frequently asked question about this scenario, Van Vlandam wrote, is how can a planet blow up? There is presently, he conceded, no satisfactory answer to this question. No satisfactory answer, that is, except the Sumerian one, the tale of Tiamat and Nibiru, Marduk, the celestial battle, the breakup of half of Tiamat, the annihilation of its moons, except for Kingu, and the forcing of their remains into a retrograde orbit. A key criticism of the destroyed planet theory has been the problem of the whereabouts of the planet's matter. When astronomers estimate the total mass of the known asteroids and comets, it adds up to only a fraction of the estimated mass of the broken-up planet. This is especially true if Ovenden's estimate of a planet with a mass 90 times that of Earth is used in the calculations. Ovenden's response to such criticism has been that the missing mass was probably swept up by Jupiter. His own calculations, Monthly Notes of the Royal Astronomical Society, 173, 1975, called for an increase in the mass of Jupiter by as much as 130 Earth masses as a result of the capture of asteroids, including Jupiter's several retrograde moons. To allow for the discrepancy between the mass, 90 times that of Earth, of the broken-up planet and the accretion of 130 Earth-sized masses to Jupiter, Ovenden cited other studies that concluded that Jupiter's mass had decreased some time in its past. Rather than to first inflate the size of Jupiter and then shrink it back, a better scenario would be to shrink the estimated size of the destroyed planet. That is what the Sumerian texts have put forth. If Earth is the remaining half of Tiamat, then Tiamat was roughly twice the size of Earth, not 90 times. Studies of the asteroid belt reveal not only capture by Jupiter, but a dispersion of the asteroids from their assumed original site at about 2.8 AU to a zone so wide that it occupies the space between 1.8 AU and 4 AU. Some asteroids are found between Jupiter and Saturn. A recently discovered one, 2060 Chiron, is located between Saturn and Uranus at 13.6 AU. The smash-up of the destroyed planet must have been, therefore, extremely forceful, as in a catastrophic collision. In addition to the voids between groups of asteroids, astronomers discern gaps within the clusters of asteroids. The latest theories hold that there had been asteroids in the gaps, but they were ejected, all the way to outer space except for those that may have been captured on the way by the gravitational forces of the outer planets. Also, the asteroids that used to be in the gaps were probably destroyed by catastrophic collisions. McGraw-Hill Encyclopedia of Astronomy, 1983. In the absence of valid explanations for such ejections and catastrophic collisions, the only plausible theory is that offered by the Sumerian texts passed by Tiamat on her outer or Jupiter side. Repeated returns to that celestial zone can account for the size of the gap there. It is the periodic return of Nibiru, Marduk, that causes the ejecting and sweeping. By the acknowledgement of the existence of Nibiru and its periodic return to the place of the battle, the puzzle of the missing matter finds a solution. It also addresses the theories that place the accretions of mass by Jupiter at a relatively recent time, millions, not billions, of years ago. Depending on where Jupiter was at the times of Nibiru's perihelion, the accretions might have occurred during various passages of Nibiru and not necessarily as a one and only event at the time of the catastrophic breakup of Tiamat. Indeed, spectrographic studies of asteroids reveal that some of them were heated within the first few 100 million years after the origin of the solar system by heat so intense as to melt them. Iron sank to their centers, forming strong stony iron cores, while basaltic lavas floated to their surface, producing minor planets like Vesta. McGraw-Hill Encyclopedia of Astronomy. The suggested time of the catastrophe is the very time indicated in the 12th planet, some 500 million years after the formation of the solar system. Recent scientific advances in astronomy and astrophysics go beyond corroborating the Sumerian cosmogony in regard to the celestial collision as the common origin of the comets and the asteroids, the site of that collision, where the remains of the asteroid belt still orbit, or even the time of the catastrophic event, about 4 billion years ago. They also corroborate the ancient texts in the vital matter of water, the presence of water, the mingling of waters, the separation of waters, all somehow played an important role in the tale of Tiamat, Nibiru, Marduk, and the celestial battle and its aftermath. Part of the puzzle was already answered when we showed that the ancient notion of the asteroid belt as a divider of the waters above and the water below is corroborated by modern science. But there was more to this preoccupation with water. Tiamat was described as a watery monster, and the Mesopotamian texts speak of the handling of her waters by Nibiru, Marduk. Half of her he stretched as a ceiling to be sky. As a bar at the place of crossing, he posted it to guard. Not to allow her waters to escape was its command. The concept of an asteroid belt not only as a divider between the waters of the planets above and below it, but also as a guardian of Tiamat's own waters is echoed in the biblical verses of Genesis, where the explanation is given that the hammered-out bracelet was also called Shamam, the place where the waters were. References to the waters where the celestial battle and the creation of the earth and the Shamam took place are frequent in the Old Testament, indicating millennia-old familiarity with Sumerian cosmogony even at the time of the prophets and Judean kings. An example is found in Psalm 104, which depicts the Creator as the Lord, who has stretched out the Shamam as a curtain, who in the waters for his ascents put a ceiling. These verses are almost a word-for-word copy of the verses in Enuma Elish. In both instances, the placing of the asteroid belt, where the waters were, followed the earlier acts of the splitting up of Tiamat and having the invaders' wind thrust the half that became Earth into a new orbit. The waters of Earth would explain the whereabouts of some or most of Tiamat's waters. But what about the remains of her other part and of her satellites? If the asteroids and comets are those remains, should they not also contain water? What would have been a preposterous suggestion when these objects were deemed chunks of debris, and flying sandbanks has turned out, as the result of recent discoveries, to be not so preposterous. The asteroids are celestial objects in which water, yes, water, is a major component. Most asteroids belong to two classes. About 15% belong to the S-type, which have reddish surfaces made up of silicates and metallic iron. About 75% are of the C-type. They are carbonaceous, containing carbon, and it is these that have been found to contain water. The water discovered in such asteroids, through spectrographic studies, is not in liquid form. Since asteroids have no atmospheres, any water on their surface would quickly dissipate. but the presence of water molecules in the surface materials indicates that the minerals that make up the asteroid have captured water and combined with it. Direct confirmation of this finding was observed in August 1982, when a small asteroid that came too close to Earth plunged into the Earth's atmosphere and disintegrated. It was seen as a rainbow with a long tail going across the sky. A rainbow appears when sunlight falls on a collection of water drops, such as rain, fog, or spray. When the asteroid is more like what its name originally implied, minor planet, actual water in liquid form could well be present. Examination of the infrared spectrum of the largest and first-to-be-discovered asteroid, Ceres shows an extra dip in the spectral readings that is the result of free water rather than water bound to minerals. Since free water even on Ceres will quickly evaporate, the astronomers surmise that Ceres must have a constant source of water welling up from its interior. If that source has been there throughout the career of Ceres, wrote the British astronomer Jack Meadows, space garbage, comets, meteors, and other solar system debris, then it must have started life as a very wet lump of rock. He pointed out that carbonaceous meteorites also show signs of having been extensively affected by water in times past. The celestial body, designated 2060 Chiron, interesting in many ways, also confirms the presence of water in the remnants of the celestial battle. When Charles Kowal of the Hale Observatories on Mount Palomar, California, discovered it in November 1977, he was not certain what it was. He simply referred to it as a planetoid, named it temporarily OK for Object Kowal, and opined that it might be a wayward satellite of either Saturn or Uranus. Several weeks of follow-up studies revealed an orbit much more elliptical than that of planets or planetoids, one closer to that of comets. By 1981, the object was determined to be an asteroid, perhaps one of others to be found reaching as far out as Uranus, Neptune, or beyond, and was given the designation 2060 Chiron. However, by 1989, further observations by astronomers at Kitt Peak National Observatory, Arizona, detected an extended atmosphere of carbon dioxide, and dust around Chiron suggesting that it is more comet-like. The latest observations have also established that Chiron is essentially a dirty snowball composed of water, dust, and carbon dioxide ice. If Chiron proves to be more a comet than an asteroid, it will only serve as further evidence that both classes of these remnants of the Genesis event contain water. When a comet is far away from the Sun, it is a dark and invisible object. As it nears the Sun's radiation brings the comet's nucleus to life. It develops a gaseous head, the coma, and then a tail made up of gases and dust ejected by the nucleus as it heats up. It is the observation of these emissions that has by and large confirmed Whipple's view of comets as dirty snowballs. First, by determining that the onset of activity in comets as the nucleus begins to heat up is consistent with the thermodynamic properties of water ice, and then by spectroscopic analysis of the gaseous emissions which have invariably shown the presence of the compound H2O, i.e., water. The presence of water in comets has been definitely established in recent years through enhanced examination of arriving comets. Comet Kohoutek, 1974, was studied not only from Earth but also with rockets, from orbiting manned spacecraft, Skylab, and from the Mariner 10 spacecraft that was on its way to Venus and Mercury. The findings, it was reported at the time, provided the first direct proof of water in a comet. The water finding, as well as that of two complex molecules in the comet's tail, are the most significant to date, stated Stephen P. Moran, who directed the scientific project for NASA. And all scientists concurred with the evaluation by astrophysicists at the Max Planck Institute for Physics. And astrophysics in Munich that was seen were the oldest and essentially unchanged specimens of the material from the birth of the solar system. Subsequent cometary observations confirmed these findings. However, none of those studies, accomplished with a variety of instruments, match the intensity with which Halley's comet was probed in 1986. The Halley findings established unequivocally that the comet was a watery celestial body. Apart from several only partly successful efforts by the United States to examine the comet from a distance, Halley's comet was met by a virtual international welcoming flotilla of 5 spacecraft, all unmanned. The Soviets directed to a Comet-Halley rendezvous Vega 1 and Vega 2. The Japanese sent the spacecraft Sakigake and Suisei, and the European Space Agency launched Giotto, so named in honor of the Florentine master painter Giotto di Bondone, 14th century, who was so enchanted by Halley's comet when it appeared in his time that he included it, streaking across the sky, in his famous fresco Adoration of the Magi, suggesting that this comet was the Star of Bethlehem in the tale of the birth of Christ. As intensive observations began when Halley's comet developed its coma and tail in November 1985, astronomers at the Kitt Peak Observatory tracking the comet with telescopes reported it was certain that the comet's dominant constituent is water ice and that much of the tenuous 360,000-mile-wide cloud surrounding it consisted of water vapor. A statement by Susan Wyckoff of Arizona State University claimed that this was the first strong evidence that water ice was prevalent. These telescopic observations were augmented in January 1986 by infrared observations from high-altitude aircraft, whereupon a team made up of NASA scientists and astronomers from several American universities announced direct confirmation that water was a major constituent of Halley's comet. By January 1986, Halley's comet had developed an immense tail and a halo of hydrogen gas that measured 12.5 million miles across, 15 times bigger than the diameter of the Sun. It was then that NASA's engineers commanded the spacecraft Pioneer Venus, which was orbiting Venus, to turn its instruments toward the nearing comet, as its perihelion Halley's passed between Venus and Mercury. The spacecraft's spectrometer, which sees the atoms of its subject, revealed that the comet was losing 12 tons of water per second. As it neared perihelion on March 6, 1986, Ian Stewart, the director of NASA's Halley's project at the Ames Research Center, reported that the rate of water loss increased enormously, first to 30 tons a second and then to 70 tons a second. He assured the press, however, that even at this rate Halley's comet had enough water ice to last thousands of more orbits. The close encounters with Halley's comet began on March 6, 1986, when Vega 1 plunged through Halley's radiant atmosphere and, from a distance of less than 6,000 miles, sent the first-ever pictures of its icy core. The press dutifully noted that what mankind was seeing was the nucleus of a celestial body that had evolved when the solar system began. On March 9th, Vega 2 flew within 5,200 miles of Halley's nucleus and confirmed the findings of Vega 1. The spacecraft also revealed that the comet's dust contained chunks of solid matter some boulder size, and that this heavier crust or layer enveloped a nucleus where the temperature, almost 90 million miles from the Sun, was a hot 85 degrees Fahrenheit. The 2 Japanese spacecraft, designed to study the effect of the solar wind on the comet's tail, and the comet's huge hydrogen cloud, were targeted to pass at substantial distances from Halley's. But Giotto's mission was to meet the comet virtually head-on, swooping at an immense encounter speed within 300 miles from the comet's core. On March 14th, European time, Giotto streaked past the heart of Halley's comet and revealed a mysterious nucleus, its color blacker than coal, its size bigger than had been thought, about half the size of Manhattan Island. The shape of the nucleus was rough and irregular, some describing it as 2 peas in a pod, and some as an irregularly shaped potato. From the nucleus, 5 main jets were emitting streams of dust and 80% water vapor, indicating that within the carbonaceous crust the comet contained melted ice, liquid water. The first comprehensive review of the results of all these close-up observations was published in Nature's special supplement of 15-21, May 1986. In the series of very detailed reports, the Soviet team confirmed the first findings that water, H2O, is the comet's major component, followed by carbon and hydrogen compounds. The Giotto report stated repeatedly that H2O is the dominant parent molecule in Halley's coma, and that water vapor accounts for about 80% of the volume of gases escaping from the comet. These preliminary conclusions were reaffirmed in October 1986 at an international conference in Heidelberg, West Germany, and in December 1986, scientists at the Johns Hopkins University announced that evaluation of data collected in March 1986 by the Small Earth Orbiting Satellite IUE, International Ultraviolet Explorer, revealed an explosion on Halley's comet that blew 100 cubic feet of ice out of the comet's nucleus. There was water everywhere on these messengers of Genesis. Studies have shown that comets coming in from the cold come to life as they reach a distance of between 3 to 2.5 AU, and that water is the first substance to unfreeze there. Little significance has been given to the fact that this distance from the Sun is the zone of the asteroid belt, and one must wonder whether it is there that comets come to life because it is where they were born, whether water comes to life there because there is where it had been, on Tiamat and her watery host. In the discoveries concerning the comets and the asteroids, something else came to life: the ancient knowledge of Sumer. Celestial seeing eyes. When the Anunnaki's mission Earth reached its full complement, there were 600 of them on Earth, while 300 remained in orbit, servicing the shuttlecraft. The Sumerian term for the latter was Igigi, literally those who observe and see. Archaeologists have found in Mesopotamia many objects they call eye idols, as well as shrines dedicated to these gods. Texts refer to devices used by the Anunnaki to scan the Earth from end to end. These texts and depictions imply the use by the Anunnaki of Earth-orbiting, celestial seeing eyes, satellites that observe and see. Perhaps it is no coincidence that some of the Earth-scanning and especially fixed-position communication satellites launched in our own modem times, such as Intelsat-FU and Intelsat-IVA, look so much like these millennia-old depictions.